Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Munder. Continue our first lecture on the introduction of object-oriented analysis and design. In the first section, we explained the meaning of an object, the difference between procedural diagram and object-oriented diagram, and what is the relationship between class and object. Today, we'll continue and explain the principle of object-oriented programming. We will also look at the minor and the major elements. So the principle of object-oriented programming basically is a framework for object-oriented system. Depends on the concept or the focus of object. The focus is on object model. Now we have major elements, we have minor elements. The major element are abstraction, encapsulation, modularity, hierarchy. Minor element, three types: typing, concurrency, and persistence. Now, major element, it should be included or in the system in order to say this system is an object-oriented system. So we cannot have an object-oriented diagram or system without having one or all these major elements. But for the minor element, they are not necessarily to be in the system to say it is object-oriented programming, but they are what? Useful. But they are what? Useful. So let's study each one separately and discuss the meaning of each one. So I'll start with the major. Okay, I'll start with the abstraction. There's an art called abstract art, which is basically, we can say it as an empty art that have a general meaning, So when you say abstraction, basically, abstraction is a fundamental way, is the way that we look at the things and try to simplify complex things, okay? If there's something complex, we try to abstract this thing and to try to get over the complexity of anything. So as an analyst, okay, there's a feature that basically concentrate on the system as an collection of objects, okay, and try to see the similarities between these objects, okay, try to avoid the small differences between objects, okay. So for example, if I say to you, when this is an example, we have a class of student. All right, we have a class of student. I'm just gonna erase this line because it is okay. We have a class of student. Okay, now the student has an attributes. Okay, we have student name, number, we have student name, we have course, we have an email. Okay, these are attributes for what? These are attributes for the student. Okay, these are attributes. Now these are also attributes. Okay, that also we can include what? The height, the weight, shoe size. Now there are two attributes, two category of attributes. Now, do we focus on this attribute or these attributes? Okay, these are, the height between students are different, the shoe size are different, but these are not really relevant to the education system. So we try to focus on what? In the things that related to the system. This is called some part of an example. So in an abstraction, we try to focus on the similarity of an object simulating the real world, okay? In simulating the real world, we try to eliminate what? We try to eliminate the small differences in these objects, okay? This also somehow focus on the outside view of the object, not into some specific behavior of the object. So try to base in the essential behavior, not a specific behavior, to serve the implementation. The focus on the system and its requirement rather than the focus on the design and the implementation. Remember, okay, the focus on the system and its requirement rather than the design and its implementation. So this is abstraction. This is kind of abstraction. We'll continue talk about and give you an example about that. So as I said, the abstraction is focused on the characteristic of the object in a general view. Try to eliminate the small differences between the objects. Okay, and remember that the objects are independent, but they cannot stand alone. They have to collaborate with each other, and somehow they have to call each other methods. Now the design or the decision design, how these objects will collaborate with each others, and what are the boundaries of each objects, okay, will be defined by the analysis. So I'll give you an example here. This is the first example for the car. Okay, this is a car, right? This is a car. This is a car. They are different cars. There's small difference between them, but they're still car. So we focus on what? In the essential details that's important to the system, and we try to avoid some of the irrelevant details. Like this is a covered car. This is not non-covered car. This is a different size of car, shape, something like that. So we treat them as a car. What is the major similarities between these cars in order to do an abstraction? Okay, like the shapes. What are the major classes? The shape. All right, and we have different shapes rather than what is the how many angle, how many small differences between them. We try to avoid that. Now, as I said, they are independent objects, but they need to collaborate with each other in order to make the system. So we have the driver who will use the car, and the car will be designed by the engineer, and the engineer will use electronic unit, and the electronic unit will be designed by the car part designer, and the car part designer will use what? These are objects, and they need to interact with each other in order to make the system. They cannot be independent. All right, they have to be in a collaboration style. The second one is called encapsulation. Encapsulation is about protection. When you say encapsulation, we say protection. All right. Now, protection by what? Protection by hiding the data from unauthorized access that could damage the system or affect the system. Okay. So the focus on this implementation that gives rise to this behavior. Now, most often, we hide the data by what? By making it somehow secret information inside the objects. Okay, we try to hide some of the secret details inside the object. In a program, okay, we can say that this is an example. We have a class, and the class contains methods and variables. Imagine this is the class boundary. All right, and inside the class we protected the method and the variable, so no other object can access that. All right. Also, when you say you ride a car, you try to switch it in and it's turned on. Do you really worry about what happened inside the engine? You don't have to worry about what happened inside the engine. The car started and then you can drive. So you can imagine that it's like more like a black box, okay, that you can use, and you don't have to worry how to know what is the secret inside that black box. So encapsulation serve this. Okay, method can be changed. If you know the single detail, the secret inside the engine, you could change that. You could do something that will make the purpose of the car is different. So we need to have somehow interface to deal with the class that has explanation. All right, this is the meaning of encapsulation. So we talk about abstraction, we talk about encapsulation. It's all about hiding. And the third one, let's give you an example in Java. I'll go to the code. In Java, when you write a class like this class, I call this class encapsulation demo. It's a sample. We have two variables. We have SSN and we have employee, three variables, employee name and the age. These variables are what? We call them as a private. When you do a private in Java, we can use public, or private. If you say public, if you define them as public, that means they can be accessed anywhere and anyone can access these elements. They are not encapsulated. But if you define them and up to private, then you hide this data inside what? Inside the class, and no one can access them. In order to access them, we have to create two methods or two behavior. It's called set and get for each variable. Set and get for each variable. This is how we implement encapsulation in Java. As you can see, we have get employee SSN, we have get employee name, we have get employee age for the three variables, and also we have a set. You can see set for the employee age, set for the employee name, and set for the employee SSN. These are three variables. If you identify the variable as a private, you need to have these three methods so the other object or classes can access the data inside this object, given an access level, a limited access level. So in this example here, we created an object of the type, of the same type as this class, okay, and we, in order to set the variable name, we use what? The functions, the method that we inside the class, set and set. In order to print out or take out the values, we use what? We use get and employee. This is how we access the data. So our access is limited by using these two functions, okay, and you can write any code in these two functions, set and get for each variable. This is how we apply encapsulation in Java. I think C# is the same, and C or plus plus also almost the same thing. Most of the language, they have this encapsulation in object-oriented programming language. So yeah, this is how they do encapsulation. They hide the data inside what? Inside like the class, more like a capsule. Everything inside it, you don't know how to do it. More like a car engine. You use the car, but you don't know what's going on inside the car. All right. The third one is called modularity. Now, the modularity is very important. If you have a problem, a big problem, like this problem, what you try to do, you split this problem into small parts or small pieces, like this one. You split it into small pieces, and you solve each piece separately, and then you combine the solution. This is to reduce the complexity of the problem, of the big problem. So modularity, if you have a big problem, you try to incompose it into smaller problem in order to reduce the complexity of the problem. So basically, decomposing the problem into a set of model, decomposing the problem into a set of model in order to reduce the complexity. The main purpose of modularity, reduce the complexity. So in programming, we split the program into components to reduce its complexity. Now we use what? We use decompose into a set of cohesion and loosely coupled model. We will look at that later on. What's the booch and what's the cohesion and coupled, the difference between them. Models serve as a physical container. The module is serve as a physical container, like a pole or a container, or anything you can imagine in our real life, and you declare the classes and object of the design inside that pot. So the principle, when you say modularity, you may apply also other principles such as abstraction, encapsulation. They all work together. Sometimes you use them when you use one of these things, so you have to use the others as well. Okay, so when you have a modularity, you will have what? You will have a boundary for the object. Okay, you will have a boundary for the object. This is an object, you have a boundary. Inside the object is encapsulated, and there's an interface or abstraction for this object. Okay, now you apply encapsulation and modularity in order what? In order to have these boundaries for the objects. Okay, now I didn't explain the meaning of modularity. So abstraction is more like looking at the general picture, Encapsulation is about hiding the data. Modularity is about simplifying the data and decompose it into small problem in order to reduce the complexity. All right, and the last one is hereditary. It's not the last one. Hereditary is more like a tree. All right, so you have ranking or order of abstraction. Look at the diagram here. We have a tree starting from the top, and then we have second level, and we have the third level. So this is called hierarchy, which is more like a tree. So the system is basically decomposed into subsystems. So this is the main system, and we decompose it into subsystem. Here this is first part, second part, third part, and then we can also decompose this one into smaller part until we get to the last level of the component. We use divide and conquer principle to do that. Okay, the main benefit of hierarchy is that we allow code reusability. We can reuse the code anywhere. So if you have a code here, you can reuse the code anywhere down in the bottom here because it's inherited. There's two types of hierarchy approach. Is a hierarchy similar to this one, which is basically decompose the program into small sub parts. Okay, there's an inheritance relationship between them. So this one inherit everything from the top, and this one also inherit from here from the main father or the main root of the tree. This is called a hierarchy. So a normal hierarchy. We can say there's part of hierarchy. Part hierarchy is define how the relationship's gonna be. It's kind of this is part of something. Like for example, the computer. I will go to the next slide. Okay, let's go to the next slide here. No. For the part of, okay, for the part of, let me explain it. For the part of, it's more like actually, but when you say this is the first object, the second object is here, but this is part of this object. It is part of this object. It's more like when you say CPU and computer. The CPU is part of the computer, all right? This is how is the meaning of part of hierarchy. So it's more like the relationship is aggregation. The class is composed of other classes. Now, this is an example of hierarchy, which is basically an inheritance. We have single inheritance. One class is extended to another class. Now, we also have the rectangle, all right, is coming as multiple inheritance from the area and parameter. And we have also hierarchical inheritance, which is most of the system will be implemented more like this. So we have the vehicle, and the vehicle could be divided into three types: land vehicle, water vehicle, and air vehicle. Even though the land vehicle can be split it into car and buses, also the water can be ship or boat, and the air could be airplane or helicopter, and you can go down and specify more and more specialization. Now if you go down, you do the specialization. Specialization, an example of specialization, your major for example is IT, but you are specialized in network, because IT has what? Has for example a database, has a software development, and so on. You are specialized in IT, in network, and then you are specialized in network security. So this is called specification or specialization. Specification or specialization. Specification, you go from the top to the down. If you want to be more generalized, you go from the bottom to the top. You say, okay, I am security in network, and my major is IT. So you say the general. So generalization, you go from the bottom to the top. Specialization or specification, you go from the top to down approach. Now, part of hierarchy as aggregation. We have two types of aggregation. We have aggregation, we have composition. When we say aggregation, we mean this class is part of the main class. So for example, we have a computer. The computer, we have CPU, hard disk, monitor, and so on. These are part of the computer. All right, like a car, we have wheel, we have engine, we have eraser, and so on. Driver. Okay, these are part of this object. So the keyboard, the monitor, the hard disk are part of the computer. This is the meaning of part of. This is called aggregation. All right, and the symbol could be drawn like this. This is aggregation. All right, the aggregation can be drawn like this. This is a simple. We'll learn how to draw the aggregation and so on. But this is just a small introduction, a quick introduction about the aggregation and composition. Composition is a very strong aggregation, which means that if you destroy the father, if you destroy this class, you have aggregation between two classes. If you destroy this one, if you destroy this one, you destroy this one, because they are strongly attached to each other. For example, the car has engine. If you remove the engine from the car, do you consider the car as a car? No. The computer has a CPU. If you remove the CPU from the computer, you destroy the computer, because the CPU is basically the computer. So this is a composition. It's a very strong relationship of aggregation. It's more like aggregation. But if you say a normal aggregation, as an example, the car has a driver or has a passenger. Okay, if the passenger or the driver lift the car, then the car is still the car. So this is what? This is aggregation. This is aggregation. All right, but if you remove the engine from the car, then there will be no car. Okay, so this is called composition. So both of them, aggregation and composition, represent this class is part of this class. But how strong is the relationship? If we can split them without destroying each other's, that's we call it aggregation. If you split one from the other, then that will cause damage, destroy one of them or both of them. Then we call this composition, which is a very strong relationship. And the symbol for composition is the same as aggregation, except that what? It is shaded. It is shaded, not like this one. This is composition, this is aggregation. I hope you understand the difference between composition and aggregation. Minor typing is we have three minor typing. You have more. I'll explain them like quickly. The first one is the minor element, which are useful in the system, but they are not necessarily to be there to consider the system and object-oriented programming. All right. So the minor are the first one is called type. Okay, now we say types, we say Java language is a typed language because it's abstract data type. You have to specify the type of the element, the characteristic of the element. Must be specified. All right, this is type of an element. Okay, so basically, you visualize the type having a property because you need to distinguish them from each other. You need to have a type. All right, so typing is an enforcement notation of the notation of an object, okay, which is an instance of a class. All right, so the object must have a type, okay, and also the different type may be generally interchanged. All right, or can be interchanged only if with specific conditions. There are two types of typings. In a strong typing, in a weak typing. There's some language considered as a strong typing, other language considered as a weak typing. When you say strong typing, the compiler will not allow you to do any operation without without compiling. So there's no run. The compiler will stop you before running the program if the operation of an object is checked during the time of compilation, such as if in language. But if the compiler is okay, and then when you run the program, the operation checked during the execution time, we call this weak typing. All right, similar to if you have X, you need to specify the type of X, integer or double or character or string. This is called typing. You have to specify this object, the characteristic of the object. All right. Typing is an example. Okay. the concept of type and the class are similar, because if you have a class, you need to specify the property inside the class and what are the operation inside the class. Okay, but typing was included as a separate element, in order just to make clear for you what's the meaning of typing. It does, in typing is must be, somehow implemented in abstraction. The picture gives you an example of typing is more like, trying to type something, but with different, there are different things. Okay, so you see the length of this one is different. For the jobs is a little bit different. For the cat, it's bigger. For the, this object is a little bit different, but it's still typing. You have to specify the characteristic and specification of that object. The second one is called concurrency. Concurrency is about performing more than one task at the same time, simultaneously, which means that, for example, you have receive an order, you fill the order, and you have two processes going in the same time. So you ship the order, and at the same time you work in the invoice and you take the payment. So this is called concurrency. It is a very famous concept on operating system. If you want to talk about it more, you can say concurrency, there's basically no operation running together, but they are switching between operation to show that these operations are running with each other. And this concept is applied in when you have multi-threading or multitasking in Java, for example, somehow. The last one is called persistence. Whenever you have a program, okay, and you create an object in that program, now the life of the object has three options. Either when you finish the program, the life of the object will be ended, خلاص done, will die the object, or the life of the object will last forever, or the life of the object will last for some times more. Okay, so in a traditional programming, life of the object basically will be, finished when the execution of the program is finished, and will be created when you start running the program. In database, you create an lifespan of the object is more than the operation itself. It lasts forever. You store information in the database, it lasts for long. All right, the probability. Now, what is the persistence? We talk about the lifespan of the object. What is the persistence? Persistence, if you create an object, okay, and this object continue to exist even after the program is finished, okay, the execution of the program is finished, but the object is still continue living, all right, we call this what? We call this persistence. Sometimes we use in the web to keep the project exist, or to keep the persistence of an object, we create a sessions and we save everything inside the session. So when this web page is خلاص finished and you go to the next page, you still have the values of the object inside the session, and then you catch them. So the persistence of the object is even after a creator ceases, still exists. This is called a persistence. This is the definition of what? Which an object continue to exist even after the creator ceases. The cease means destroyed. To exist is known as what? Persistence. Remember this definition. All right. Now these are the summary of the lecture. So we explain in the first part what is the meaning of an object, and we explain the link between the object and the class. We explain the difference between procedural language and the object-oriented language or diagram. We explain the main concept in object-oriented analysis and design, which are there. We have a major element and a minor element. We say the minor element are useful but not necessarily to be in the system to say the system and object-oriented analysis. The major element has to be in the system in order to say that this system is an object-oriented, such as abstraction, encapsulation, hierarchy, and so on. We also explain that how these objects interact with each other by using implemented by a class, and they can exchange a message or call each other methods in order to collaborate. And we introduced the concept of inheritance by using single inheritance, multiple inheritance, hierarchy inheritance, and we talk about something called generalization, and which goes from the bottom to the top, and specification, which goes from the top to the bottom. And we took an example as an IT. This lecture will cover learning outcome number one. That's it for this today. If you have a question, you can email.